Right, lowest common multiple. We're going to use the algorithm that is presented here in the spreadsheet, where you have two numbers, 15 and 6. 15 times 1 is 0, 15 times 2 is 15. No, it's actually not, is it? 15 times 0 is 0, and so on. So, and 6 is our second number. So in this program, the user is going to choose, I'm actually recording, so the user is going to choose one of these numbers here, and then, well, they're going to enter a number there. First number, second number. We want to know what's the lowest common multiple of those two numbers in our button click event. I'm going to use this algorithm that we figured out that the second number, if it goes into one of these multiples without any remainder, then that multiple itself is the lowest common multiple. So I've declared a variable called LCM. I've got a counter that's going to be the counter for multiplying by 0, 1, 2, 3, 4, and so on. I have variables for inum1 and inum2, and we're going to repeat until the multi is 0. I multi, I've made a variable called I multi. Repeat, so we get our lowest common multiple. Well, I'm calling it an LCM, is I num1 times k, so k is 0 to start off with. And then we get I suppose I should have called it I mod, or I mod, I remainder. Let's call it I remainder to be very specific. It's very important that we do use very specific variable names. Otherwise, we could get confused in our code, as I've just shown you now. R multi is actually the remainder of dividing the second number into the actual LCM, not I num1. That I num1 is supposed to be LCM. The remainder is taking that lowest common multiple that we multiply by k, which is from 0, 1, 2, 3. So our remainder is this number of how much is remaining after dividing. But the LCM is this number here, 0, 15, 30, 45, 60. And each time we're multiplying it by the progressive integers from 0. And we calculate the remainder each time after we have calculated that. So the remainder is LCM mod I num2. So if the remainder is 0, then we've got the LCM. Okay? We actually don't, we can actually put a Boolean flag here rather. Or we can actually delete this altogether, these two lines. Why do I say that? If I delete these lines, that if statement, what's going to happen here now? Until I remainder, so there was something wrong with my algorithm. Repeat until I remainder equals 0. Now this is what's going to happen when you try and solve a problem. You're going to find, oh, okay, that's not supposed to be like that. Let's do it another way. So we repeat, getting the lowest common multiple is I num1 times k, okay, fine. Getting the remainder, the lowest common multiple mod the second number, increment k is for our next loop, and we're going to do that until I remainder is 0. So what's going to happen? The next number will be 1. So LCM will be I num1, 15 times 1, which is 15. Remainder will be 15 mod 6, which is some number. Increment k, which will now be 2. Can you see remainder is not equal to 0? And then we will repeat again. LCM is I num1 times 2. 15 times 2 is 30. Our remainder is 30 divided by 6. What is our remainder? Which will be 0. That k can be incremented, but guess what? The processor will stop right there. If the remainder is 0, that until part will not happen. So we can go and safely put this code in. I feel confident that it's correct. We'll display the actual lowest common multiple here in label 1. So here we go with our program. Double click the button. Let's get some variables in here. Our remainder, I'm going to use them just as I had them. num1, num2. Get our integers from our edit boxes. Our spin edits. I didn't change any names of them because we would spin edit 1 dot value and num2 and edit 2 dot value. Can set k equal to 0, and then we're going to repeat until our remainder equals 0. So what are we doing all the time? Well, we have to have an LCM variable as well. LCM. Take note, we're dealing with integers only. 1 times k and then our remainder equals LCM mod num2, and then we'll increment k, and that is it. So I've taken that straight from my algorithm that I devised over here in this spreadsheet. We'll just display label 1 dot caption colon equals LCM. What if there aren't any lowest common multiples? Well, it'll be a good idea to say LCM equals 0 right at the top there, in case we put in two numbers where there aren't any common multiples at all. So we can go put that code in, and then we're going to run it. Okay, I'm going to run my program to double check that it's correct. And we're dealing with two numbers here. We had 15 and 6. And we know that it's supposed to be 30, but why does it say 0? Okay, we have to trace through our program and double check, but let me just try one more thing. Still 0, so we have an issue here. Right, I use 15 and 6. So num1 is 15, num2 is 6. K equals 0, okay, LCM is num1 times k. So that'll be 15 times 0, wouldn't it? And, hey? Yeah. I'm saying LCM, yes, it's times 0. So our remainder will be LCM mod num2. Well, you actually can't divide by 0, so that's an issue.
That's why LCM is equal to 0.
Yeah, we're going to start with 1. K equals 1. So that would be better. K equals 1, so LCM equals num1 times 1. So if num1 is 15, the lowest common multiple will be 15. Okay, we've got that one. Our remainder is 15 mod 6. Okay, we increment k. K is now 2. LCM is num1 times k, which is 15 times 2.
And the program works now.
Yeah, because I changed that k equals to 1. Because it was dividing over there. You can't do division by naught. Naught, yeah, that was giving a problem. But let's set LCM equal to naught. There will always be little bugs that you have to fix when you try and solve a problem. So there it is, fine, 100%. Okay.